Teach me about the Great Lakes. Teach me about the Great Lakes. Welcome back to Teach Me About the Great Lakes, a twice monthly podcast in which I, a Great Lakes novice, ask people who are smarter and harder working than I am to teach me all about the Great Lakes. My name is Stuart Carlton. I work with Illinois Indiana Sea Grant at Purdue, and I'm joined today by the fixer himself, Ethan Chitty. Ethan, how are you today?
Howdy, howdy. We're doing great. Living the dream.
Living the dream. Excellent. Remind me to ask you about that later and how one lives the dream. One way that you might do it is by doing a lot of outdoor activities during the winter. But the outdoor activities that have been available this winter have been slightly different from the outdoor activities that are available in other winters, since we've had more days in the 50s in the last couple of weeks than we have in the 30s. And so I was actually wondering about that. And I thought it would be interesting to talk to someone who knows and talk about sort of the warm weather we've been having, why, maybe the effects on lake ice and things like that. And so we've actually asked a guest, well, you know what? We're going to jump right into it. But first, since our guest is a researcher, we all know what time that means. Researcher feature. A feature in which a researcher gonna teach us about the Great Lakes. Our guest today is Dr. Richard Rood. He's with the Department of Climate and Space Science at the University of Michigan College of Engineering, and he's also a Dow Sustainability Distinguished Faculty Fellow in the College of Engineering, the School for Environment and Sustainability at University of Michigan. Richard, how are you today?
I'm great.
Fantastic. It's good to be great. So we want to talk a lot about climate science and lake ice and how the winters are changing. But first, I always like to think about origin stories because I think of scientists as superheroes because why not? So what is your origin story? Was it like a radioactive spider? Was it that you grew up as kind of a nerdy kid? What was the deal?
I never thought of myself as a nerdy kid. I grew up in a family that did have scientists and have a long history, in science and science education. My brother was a Cold War kid that looked for Soviet satellites in space, and he became an astrophysicist. I sort of followed in his path. I became a physics major, which I didn't really like that much, and I liked fluid dynamics. So I converted over to meteorology in graduate school, started to study ozone, did well in that. After that, I worked at NASA, and because I'm a natural systems thinker, one of the things that happened at NASA is I started to get put in charge of things. So I did global modeling, I did data assimilation, I did supercomputing. Then I got tired of management. Michigan recruited me, and I came to Michigan and really changed my research focus and what I do and how I think about things.
Interesting. So that was a big career change for you, right? What was it that drove you to that? So you're interested in fluids and stuff like that. I mean, who isn't? It just depends on what fluids you're interested in. But what drove you to sort of really take on climate as a bigger part of what it is you do?
When I was recruited to Michigan, there was not a lot of climate emphasis in our Department of Climate and Space Sciences. And there was a desire by the leadership then to give it more of a climate, culture to start to develop that. And I came there, and the second or third day I was there was a conference. And that conference was on climate change. It was sponsored by the Ross School of Business. I don't know what I said in that conference, but at the end of it, 3 students, 2 business school students and a public policy student came up and asked me to start a class on climate change and its relevance to society. And that completely redefined my career and at some level what I do in life.
And so when was this?
That was in 2005 was when I moved to Michigan, and we taught the course for the first time in the winter of 2006.
So 2005 was Hurricane Katrina. When did An Inconvenient Truth come out? That was right in then?
It was right in there as well.
What do you think was driving the students to feel that? I think it's really important, but why What was in the air at the time? Is it just something about Ann Arbor, which is a progressive town, or what?
I don't think it was particularly about Ann Arbor. I think that there was an awareness. The interesting thing to me, I've had sort of three changes in my teaching philosophy. And the first one occurred very quickly because it turned out that those business students and policy students really thought a whole lot more about climate change and its consequences than the students in science had. The students in science were very focused on their particular aspect of the field and did not really think about it in context that much. And I think that these students needed to feel confident that they understood the science well enough that they could use it in their professions. And they were not seeing that. And they saw a general lack of climate science at the point in time at the University of Michigan. But there was a lot of hope then because, even, many prominent Republicans, such as John McCain, were very much talking about climate change. Obama got elected. There was legislation moving on it. But then, politically, it started to all fall apart.
Well, let's pull it more locally. So that's kind of how you got here, and it's sort of a story of moving around a bit, which is very common for people in academic jobs, right? And I was thinking about that because in my family we've moved around a bit, and one thing we always talked about was we wanted to get to a place where there were 4 tolerable seasons, 4 nice seasons. And I did a postdoc here back in 2012, 2013. And we said, well, that's not Indiana because the winter is too cold. And so we moved back here, though, and we found out that, well, not anymore. The winter is not too cold anymore, or at least it hasn't been. This particular winter, we had about a 3-day stretch where it was -10, -15, negative way too many. But other than that, we've had probably more days where the high is in the 50s than when the high is below 30, which is somewhat anomalous, but maybe not. And so my question is, so this is a warm winter. Before we move into lake ice, what determines whether a winter is warm or cold? Why is this winter warm compared to others?
I'll say the pattern that you experience this year where it's warm with a cold air outbreak is what I would say is the pattern you're going to see in the future. And what often determines the characteristics of a winter, whether it's warm or cold, would be these waves in the atmosphere. And if you were to look at a map of the United States when it's really cold in the east and the southeast, it's almost certainly very warm in the Northwest and perhaps even in Alaska. So you always see this pattern of warm and cold oscillating like a wave. And so what sets up whether it's a warm winter in the east is whether or not that wave is stuck or stays in a pattern for a long period of time. So weather like that, weather on scales of persistent anomalies, they're called, which are related to all sorts of things in sea surface temperature and mountain ranges where they're located. They set up a winter, whether it's going to be warm or cold or wet or dry.
In this pattern that sounds like it's going to be happening more and more, that gets me thinking about lake ice, right? Because that's something that's very important in the Great Lakes. We spoke with Dr. Sapna Sharma, way back in episode 42, which you, listener, can find at teachmeaboutthegreatlakes.com/42, about lake ice. And she talked about some of the dynamics, but also about the cultural importance of lake ice. And so this has to be affected. First of all, if you could tell me, what does lake ice do? I guess that's my question. What is sort of the ecological or physical science role of lake ice in the Great Lakes?
Lake ice is important in many aspects of the climate system. The thing that people think about first is that when the lake freezes, it cuts off the evaporation. And it's like putting a thin layer of plastic on top of some water. It's no longer communicating with the atmosphere as much. And when you turn off that evaporation, you change the characteristic of lake effect precipitation, lake effect rain, lake effect snow. So the lake ice is tremendously important to both the type and the amount of precipitation that you get in the winter. The other place, or another place that lake ice has a big effect, is that ice, takes a long time to melt. Once you have a big pile of snow, it stays there. So if the ice is not there, then the water warms up faster in the spring and the summer. There will, of course, be biological changes related to that because, the fish in the Great Lakes are warm water and cold water fish, so things change like that. But that persistence of the ice late into the season, sometimes it can be even remembered the next fall if it had been a really big ice year. We did a paper on Apostle Islands and ice in the Apostle Islands. And we're not the only one to notice this, but there's a very big shift in the behavior of lake ice in about 1998. And since 1998, the onset and the duration of lake ice has been much smaller.
Okay, and so going forward then, this is just the new normal, isn't it, at this point, and for at least a while, and then the new normal will get worse over time, depending on what we do.
Well, actually, in my somewhat, I don't think I'm contrarian, but I think I'm nuanced. One of the things that I have objected to is the idea of a new normal, because it's not like we're shifting to something and staying there. We're in a time right now of incredibly rapid change. And so if there is something that's normal right now, it is that we're changing. And I think it's really important thinking about the lakes or climate change in general, that during this period of change, it could go on, all evidence right now is it's going to go on for decades. If we do an effective intervention with mitigation, we might limit it and stabilize. But what's true now in 30 years is likely to be very different from what's true in 60, 90, or 100 years. And so this change in variability is, I think, the new normal, is that we're getting more variable.
Now, with that, and this is since about 98, downstate, we've had a lot of instances where we have smaller ponds that go through really intense freeze thaw cycles rapidly. And we have these giant fish kill-offs as a result of that. Now, with the actual Great Lakes, is that something that you're seeing, those really fast freeze and thaws, or is there just too much mass to make that actually happen up there?
So in the lakes, you don't see the whole lake freezing or thawing because it's too big and it's too massive.
It's not so much devil's advocate, but it blows my mind that, whenever we talk about limiting climate change, they talk about 2 degrees Celsius, which is, 3 or 4 degrees Fahrenheit, right? And so we haven't even seen at this point, we're hoping to limit it to that, which means we've had less than that. It boggles my mind that a degree or 2 of warming can have these huge differences, right? I'm not saying that they can't. I'm not denying. I'm just, how is it that happens? Is it because of the difference between an average, and sort of what you're actually seeing that makes up that average, or what is the, how does that work?
So if you look at, this idea of a degree or 2 warming, and another part of my transition in teaching in 2008, I decided it was disingenuous to keep talking about limiting it to 2 degrees. And we don't have any evidence right now that we're going to do that, but that's perhaps a different story. If you look at that, that's a global average, and that is a global average of sea surface temperature and surface air temperature. If you think of where most of the heat goes in the ocean, and most of the ocean is in the tropics. So it takes a whole lot of energy to heat up the ocean and to get to that 2 degrees. But if you look locally, as you go to the higher latitudes and in your own land, we've already seen significantly more than 2 degrees warming. And some places in the Arctic, we've seen warming that's, beginning to approach 6, 8, and 10 degrees. which is why you're seeing those gigantic changes in sea ice, and you're starting to see the melting permafrost. In the Great Lakes region, you're seeing land that used to be frozen is not frozen right now. So there's locally there's been a lot more than that global average, and this characteristic of it warming far faster at higher latitudes, which is called polar amplification, is actually just part of the signal of greenhouse warming. That's what we would expect. This latitudinally dependent, land ocean dependent regional characteristics of the warming.
So in other words, right. So it is just a global average, and then any average, whether it's, it could be baseball or like basketball, right? If you average making about 40% of your shots, you're going to have some times where you're making 60 or 70%, sometimes you're making 10. And so the same with temperatures, in that there's going to be some places that get a lot more to make up for the fact that the tropics are going to get a lot less. I think that makes sense.
Right. And the tropics are getting more energy, but because of their mass, they're heating up more slowly.
That's why I heat up slowly, my extreme mass.
Yes, we have the same affliction.
That's interesting. But so you sort of mentioned that you seem to be really thoughtful about this, and maybe you're a contrarian or you speak with nuance, and you think about, like, we shouldn't talk about limiting when there's no evidence of being limited, but you work a lot in this field, and I think that's part of what you're doing with openclimate.org, right? What is Open Climate, and how are y'all working on solutions related to this very hard problem?
Well, so openclimate.org is my personal brand, and where I put out my lecture materials and some of where I aggregate some of my writings and materials. One of the things with Open Climate is that one, I feel as if climate science is more accessible than a lot of people do. I think it's simple physics in complex systems, and that the basics of understanding it need to be widely shared. The demand from my students needs, that it needs the societal implications is one of my motivations for Open Climate. One of the interesting things that has happened with that, and I'll give what I'll call my premier example, is that right before the pandemic, a group of very motivated and outstanding teachers from the science and math school in Battle Creek, Michigan, contacted me about teaching climate in high school. And subsequently, that group of teachers, and in particular one teacher, Tim Muick, have created and taught more than one time a course in high school that also spans climate and society, but he tuned it for them. And so one of the things that I'm trying to do with Open Climate is get engagement like that and to build more educational materials. My materials have also been adapted in the med school at the University of Michigan, which has been one of the first times in a med school, definitely the first time that our med school started trying to integrate climate change into the training of physicians.
On your website that you've got quite a wide variety of materials there. If somebody was interested in kind of diving a little deeper into what you've got there, where would you start them off?
On the website, there are two places that I would actually start them off. If you look under resource, I have a resource blog, and the resource blog, I try to aggregate information in of different sorts there. And then over under classes, if you do pull down on classes, I have many courses, and then I've also developed something that I'm not going to remember the name of right this second, topical collections. And so I have topical collections, and I often generate those based upon themes that keep coming up in class. And I try to aggregate materials there. So that's where I would send people right now, would be the classes tab and the resources tab.
Excellent. And we will do that actually again with links to our in the show notes, which you can find at teachmeaboutthegreatlakes.com/75, because this is episode 75 of this adventure. Oh my goodness. Time keeps on slipping into the future. Well, Richard, this is really interesting to hear you talk about the work you do in lake ice and teaching us sort of the biophysical importance of it as a sheet of visqueen on top of that's not precisely how you put it, on top of the lake. But that's actually not why we invited you here on to Teach Me About the Great Lakes this week. The reason that we invited you on Teach Me About the Great Lakes is to ask two questions. And the first one is this. If you could choose to have a great donut for breakfast or a great sandwich for lunch, which would you choose?
It's very tough. I think I, at this point, have to choose the sandwich for lunch.
And so if I go to Ann Arbor, and I don't want to hear Zingerman's, do not say Zingerman's, we know Zingerman's, and I want to get a sandwich, and I ate breakfast, I had a bagel at Zingerman's, so we don't want a double zinger. Where should I go in order to get a really great sandwich?
The place I go, it's almost become a little bit of a comfort place for me, is Red Hawk.
Red Hawk.
Which is an old bar down on, it's a sort of a traditional Ann Arbor bar place that has a nice sandwich, and I like the Reuben there in particular. So the Red Hawk would be one. Yeah.
If you've got somebody coming to the Great Lakes and you want to show them a special place that you wanted to share with members of the audience, where would that be, and what kind of makes it special or different from the rest of the Great Lakes?
Well, it's a long way from Ann Arbor, but I would probably take people up around the dunes because they are, one, it's protected, nice area. Well, I guess there's Indiana dunes, and then there are the Great Dunes. Great Bear, the dunes up on the northwest coast of Michigan, and the national park up there, national shoreline up there. And aside from it being, well kept and a nice place to go, there's such an interesting sort of geological history there of the remnant of the Ice Age deposits. And then you can also see the effects of lake levels as you see the rise and fall of the lake levels. So it's also a nice educational place. But I came to Ann Arbor sort of mid to late life, so I actually don't have all of the intuition that I would have on that. I have done an adaptation study for Apostle Islands. That was nice. And if I had the time, I'd send them to Isle Royal, which we've also done an adaptation study for.
So what is an adaptation study? When you say, just out of curiosity, now we're getting far afield again, I apologize, but are you looking at predicting climate changes and what they might need to do? Is this kind of a multidisciplinary thing or what?
When I moved to Michigan, my research changed, that I'm doing research into how to use climate data, climate knowledge, actually more than climate data. And one of the first, and I think the best projects, is Isle Royal. And when this technique is used well, and in this case, the Park Service actually introduced and sort of led the technique of scenario planning. They have some management problems, and they have a very particular management problem on Isle Royal, that they have this wolf moose ecosystem. And for years, the wolves have been in decline. There has been a theory that the wolves actually got to the park and kept keeping their population going because the lake froze and they walked over from Canada. And so the lake's freezing west. So here's another place that lake ice has an effect. But it was getting down to, I think they may have even gotten down to one wolf. And the question was whether or not they should reintroduce wolves. So from a climate perspective, the answer is climate change is not working for that ecosystem because, one, if it's disrupted, there's remnant boreal forest there. Boreal forest will not grow back there in the new climate. The moose is dependent upon the browse in that forest. The thermodynamics of the moose require it to be cold, so it's getting warmer. The moose doesn't it's not a good environment. So from a climate perspective, we can inform the park that they're going to have even more challenges from a weather and climate perspective moving forward. Now, their priorities, are listed. They have many other priorities, including that's the culture of that park. That's what people come there for. So we try to inform them of how to think about climate change in that adaptation.
Well, on that semi-depressing note, maybe hopeful in that we're at least thinking about things. I'm going to go back to thinking about Red Hawk and get a room in there maybe. But Dr. Richard Rood, who is a professor in the Department of Climate and Space Science at the University of Michigan at College of Engineering there, and a Dow, one of several of the prestigious Dow Sustainability Distinguished Faculty Fellows in the College of Engineering in the School for Environment and Sustainability. Nope, just one sustainability in the School for Environment and Sustainability. Regardless, thank you so much for coming on and teaching us all about the Great Lakes. Great. Well, that was fascinating. There's a guy who can talk about almost anything, it seemed like, related to climate change. And so I learned a bit about lake ice and some other things as well. It reminds me of a poem my kids were really into, which is, it seems like our weather is going to be variable, right? So kiddos, if you're listening, I think you can recite along with me. And this is from the Waldorf Book of Poetry, edited by David Kennedy, but it's written by our good friend Anonymous. And that is, whether the weather be fine or whether the weather be not, whether the weather be cold or whether the weather be hot, we'll weather the weather, whatever the weather, whether we like it or not. And that seems to be the story for the Great Lakes going forward.
That is quite a tongue twister there. I'm glad that you were doing that, not me.
Ethan had to step out for a minute, and in the meantime, it's time for Great Lakes News. And now it's time for the Great Lakes News. Here's your host, Stuart Carlton. Thank you for that, Stuart. And it is time for the Great Lakes News. We are joined today not by Sandra Swoboda, who is on special permanent assignment with the Attorney General of Michigan. She has left Great Lakes now, but we are super lucky to have Anna Seisling joining us. Anna, how are you today?
I'm doing really well, Stuart. Good to be with you. How's it going on your end?
It is super plus awesome, because why not? It's, it's January. It's cold. You know what? I'm going to stick with the super plus awesome rather than reflect on it much. I don't want to know the details. All right, so here we go. So it is, we're recording this at the end of the month. It's being released early in February, but this means that you have just released a new episode of Great Lakes Now. Is that right? So let's do the rundown. What are we covering in this month's episode?
Yeah, that is correct. A new episode just dropped on DPTV. Of course, it's going to go out and be made available to all of our member stations. It'll be on the Great Lakes Now YouTube channel. It is called Smart Sewers and Sunken Aircraft. And just to sort of give you a little brief overview, essentially, it's a look at a high-tech approach for keeping sewage out of waterways that's taking shape in South Bend, Indiana. We take a look at a story behind World War II era aircraft that are sitting at the bottom of Lake Michigan. And then, of course, yours truly catches everybody up with The Catch, which offers even more news and headlines from around the Great Lakes.
Fantastic. And everybody, you should go right now to greatlakesnow.org, click on the YouTube link, and go listen to it. But let's talk about these stories in a little more depth. So story number 1, smart sewers. What is a smart sewer?
Well, I mean, if you don't really know what a smart sewer is, you're not alone. I was right there with you prior to this segment. So essentially, to kind of give you a little bit of backstory, the city of South Bend, Indiana once had a really big problem. And that issue essentially was too much sewage was being pumped into the St. Joseph River. That eventually flowed into Lake Michigan. Obviously not a good thing. So the U.S. government ordered the city to do something about it, but the price tag was huge. So essentially, desperate for a solution, city officials found a smart solution.
Smart.
See what I did there? Right under their
Yes.
noses. And essentially it was figuring out this kind of smart sewer system. So what ends up happening with combined sewer overflow issues, which is something that the city of South Bend had, essentially during heavy storms, all this dirty water, it can overwhelm the city's water treatment plant, causing what is called a combined sewer overflow. So basically, in 2012, under a federal consent decree, the EPA ordered South Bend to clean up its act, and the plan was to build an enormous underground holding tank. But like I said, the price tag was too high. It was like $1 billion. So city officials went in search of this solution. And essentially, they ended up finding that right up the road at the University of Notre Dame, engineering students were working with the U.S. Defense Department to develop embedded devices or smart sensors to track down terrorists in remote areas. So the thought was that if these sensors could be used to monitor bad guys, they could also monitor sewer pipes in South Bend during heavy storms.
At a minimum, right. They could. All right. Yeah. So the original plan was basically just a huge shared underground latrine, and that's out the window. And so what do these things monitor exactly? So my sewer system has a regular level of intelligence, whatever that is.
Right. Yeah.
But these are smart. And so they have the sensors. What do the sensors do?
Yeah. So the sensors coupled with these smart valves, basically it works to find empty space in South Bend's 600 miles of sewer pipes. And it uses that space to temporarily store huge amounts of untreated wastewater that would otherwise find its way into the St. Joseph River. Not anymore, though, with these smart sensors, these smart valves. So essentially, what ends up happening is that, 75-80% of the problem is solved without having to build anything. It's just using these sensors and this existing infrastructure underground. It's pretty incredible.
That is pretty incredible. Excellent. Smart sewers. Notre Dame.
Yeah, love it, right? And it ended up too, I should let you know. So city officials that were interviewed for that story, they estimate that the city has saved something like $450 million with this technology. So, note to any other city officials listening, you could be saving some big bucks and creating a better water infrastructure system for your community.
I feel like I did not even know how much sewage cost. I feel like sewage is who knew? I did not. So next on the list, I wrote down World War II planes. Is that on the list?
Yes, that is on the list. I'm, I should say, partial to this story. I went out and was field producing it at the Air Zoo in Kalamazoo, Michigan. So to kind of give you a little preview before we get into specifics. So essentially during World War II, the Navy trained nearly 15,000 pilots to take off and land on makeshift aircraft carriers on Lake Michigan. I think a lot of people don't know about this. So during the course of the training, 130 planes ended up at the bottom of the lake. If you're like me, you're probably thinking, oh my God, does that mean 130 pilots died? No, it does not. Something like, it was like 8 to 12 pilots.
I'm not like you. What I was like is, I wonder if we can get someone to go scuba diving there. So, yeah, the pilots too. I'm glad. So glad that it was 130 pilots. Yeah.
Essentially, though, you're right on track thinking about getting these aircraft out of the bottom of the lake. So essentially now there's an effort to rescue and restore some of these planes. And Great Lakes Now went and visited the Air Zoo in Kalamazoo, Michigan to get a closer look at the efforts. And what I can tell you, so many volunteers and so much enthusiasm goes into like years long restoration efforts. Everything from first locating where the planes are at the bottom of the lake, pulling them out, and then like painstakingly with soapy water, cleaning all the parts and making them look beautiful. It was really, really cool to see up close.
That is really cool. I'm going to have to find out about that. I'm going to watch this segment and then we're going to try to recruit somebody to be on the show because I'm curious about that. Anytime there's a shipwreck, we talk about shipwrecks, nonstop shipwrecks, but this is maybe even one step farther talking about plane wrecks.
Well, and I should say too, Terrace Lisinko is the person who is kind of responsible for organizing the actual excavation of these aircraft. And when I asked him, how did you get into this? He said, well, I love adventure, Great Lakes, and so many people are all about the Great Lakes shipwrecks. Not as many people are into the aircraft. So he essentially kind of carved out a little niche for himself and is working on getting these aircraft out and also kind of, sharing the story about this entire thing that not a lot of people know about this pilot program.
That is amazing. I cannot wait to look into that. Very cool. All right. And then last but not least, the catch. So the catch is like your little, it's your version of Great Lakes News, if you will, with a different theme song, I think. But and so in there, one story caught my eye because I was very concerned about this idea. I'm from the Gulf South. And so one thing we always have to worry about is jellyfish. And so what I tell my kids about the Great Lakes, we go up to swim, is I tell them two things. You're not going to get eaten by a shark, probably. Unlikely. And you don't have to worry about jellyfish. But now it turns out maybe I have been lying. There are jellyfish in the Great Lakes too.
You have been lying. But what I can tell you is that, you're in good company, because I've actually swam in this area where apparently there are Great Lakes freshwater jellyfish. And I didn't know about them. A big part of the reason is because they are really tiny. So like you said, the catch is essentially a segment where it's a news roundup. So I'm going around. I wish I could say I was the one doing all of this, wonderful investigative reporting about these freshwater jellyfish. But I actually ended up talking with a reporter at MLive. Her name is Michaela Coffey. She's been reporting on this group of college students that actually tipped her off to these freshwater jellyfish. So these college students are at Eastern Michigan University. They're studying freshwater jellyfish in Dexter Township, Michigan. So a lot of people don't know about the jellyfish, but they've actually been here for decades. And according to Michaela, a lot of the researchers seem to think that they come from what is called the Yangtze River Valley in China, and that they were actually transported here with ornamental aquatic plants. Pretty interesting. And like I said, very tiny, but venomous, but also because they're very tiny, not going to do a lot of damage to humans.
Well, that's good. I'll just have to keep my pinky finger away, I guess.
Yeah.
But so these are invasive then. I did not realize. I mean, oh my goodness, we have tons of people doing invasive work at Sea Grant, and I did not know about these jellyfish. Do you know if they're causing ecological concerns, or do we not know yet?
My understanding is that they're still sort of being studied and being looked at, sort of the implications of their presence, just how many there are, and kind of, what the future of the ecosystem within that particular body of water, and also within the larger region as a whole, what it might mean to have these jellyfish here. But as of right now, it was sort of just the students looking at them, capturing some of them, looking at them in labs, and kind of trying to figure out, what does their presence mean to the existing ecosystem?
One of the things that we talk about a lot is the idea of a goby dog sandwich. All right, so these round gobies, right?
Yes.
They're yeah. And so my thought, if my line of work doesn't work out, is they're kind of hot dog shaped, right? And so my big theory is that I should make a goby dog stand. You take the gobies and you put them in the bun. You put the little pickle on them and the celery salt or whatever, and you sell them in Chicago. I've been told by many people this is a horrible idea, but those people are small-minded. But it just occurred to me that now we could also have a peanut butter and jellyfish sandwich. And
Stuart literally you took it out of my mouth. I'm right there with you. Peanut butter and jellyfish sandwiches. Why not?
Well, for $4, you can put it right in your own mouth. I just have to design it first. Fantastic. Well, if people want to go and listen to this episode, where should they go to?
Everybody can check out everything that I just mentioned and so much more at greatlakesnow.org. That is the spot. You can see the landing page. You can see a map. You can see related segments and extras and read and watch even more about all of these stories. greatlakesnow.org.
Yeah, and y'all have educational materials. Or if you're listening, go there. You got lesson plans. It's all the best stuff. Fantastic. Thank you so much for bringing us news from the lakes we love, Anna Seisling. And we will see you next time on Great Lakes News.
Sounds great, Stuart. Thanks.
Teach Me About the Great Lakes is brought to you by the fine people at Illinois Indiana Sea Grant. We encourage you to check out the great work that we do at iiseagrant.org or ILIN Sea Grant on Facebook, Twitter, and other social media. No Mastodon. We don't have a Mastodon. Do we need a Mastodon?
They went extinct.
It went extinct, but Phoenix-like, they are rising again. Carolyn Foley is our senior producer, and our producers are Hope Charters, Megan Gunn, and Irene Miles. Ethan Chitty right here, associate producer, fixer. And our super fun podcast artwork is by Joel Davenport. The show is edited by the awesome Quinn Rose, and I encourage you to check out her work at aspiringrobot.com. If you have a question or comment about the show, send us an email, teachmeaboutthegreatlakes@gmail.com, or leave a message on our hotline at 765-496-IISG. Hey, everybody, thank you so much for listening, and as always, keep grading those lakes.